what comes to your mind? Okay, let me tell you what should come to your mind as a concept. The first thing is you're dealing with a situation like a multiple torque situation, right? This is what you're dealing with. You have multiple torques being applied on this body. It's a rigid body. When multiple torques are involved, right? Each torque has its direction and magnitude, clockwise, anti-clockwise, and stuff like that, right? And therefore, after you calculate the individual torques, right, which is using R cross F, which I have written here, right? What you need to do is add the torques and see what is the resultant torque. So this question has two torques, right? So this is one and this is second. And what are we supposed to find? We're supposed to find the resultant torque on this body, right? So resultant torque is sum of individual torques. Individual torque, you will worry about magnitude and direction. The formula to calculate individual torques is given here, right? So let's calculate the individual torques about the center of the wheel. This is where we need to find what is the resultant rotational force or the torque being applied. Let's calculate T1. The torque, which is because of the first force, is equal to how much, right? So you can see the overall diameter is 2 meters. This becomes 1 meter, right? So this is your 1 meter. So the torque being applied, and it is what? Anti-clockwise. The torque is anti-clockwise. So 2 multiplied by 3, right? And the second torque which you're applying is with the help of the second applied force, which is 2 newtons, okay? And so therefore the second torque. And what is the direction being produced by 2 newtons? Again, anti-clockwise, right? So this is 2 into 1 is equal to 2 Newton meters. So both the torques are being applied in the same direction, right? Which is anti-clockwise. To find the resultant torque, you will do sigma of the torques, which is the sum of the two torques, to be 6 plus 2 is equal to 8 Newton meter. That's your answer. Okay. Very, very useful question to understand situations where you have resultant torque as a question because of the multiple torques being applied on a rigid body. One very important thing I want to tell you is some questions may have a situation where they ask you to calculate, the overall rotation does not happen, which means the resultant torque is zero. And you may be given a third force at certain distance, and you may be asked at what distance that force needs to be applied to make the resultant torque to be zero, which means the body is in equilibrium, rotational equilibrium. So what you will do is you will put that torque as minus 8 Newton meter, which is reverse of anti-clockwise. The force would be given to you. You can find the distance of the force from the pivot point, R, right? So R, in this case, whenever you calculate the formula of torque, R is called the distance from the pivot point. For example, the distance of 3 newtons from the pivot point is 1 meter. The distance of 2 newtons from this place is 1 meter. This is called the concept of pivot point. How far is the force now from the pivot point when you drop a perpendicular from the direction of the force? So you can see this was a perpendicular. This too was perpendicular, right? Therefore, theta in both the torques was 90 degree. It is very important for you to understand these things because the sense of direction and the proper application of torque as a formula has a theta involved, which is the angle between the applied force and the perpendicular distance of the pivot point from the direction of the force. I hope this helped you and made you understand as to how to solve the questions of resultant torque, and maybe sometimes when the question is on rotational equilibrium, the total torques, the resultant torques have to be zero. I hope it also gave you an insight into the pivot point and the angle between R and F vector. which in this case, fortunately for both the situations, was 90 degrees. Thank you very much. Don't also forget to join my community, because my community has thousands of questions being put. If you're preparing for any entrance examination, it is going to benefit you immensely when it comes to solving the physics problem. Thank you very much.